Alright, this is Mr. Hill with a tutorial on how to use an algorithm to solve a division problem. I'm going to show you two algorithms. Don't let the word algorithm scare you. An algorithm is just a set of steps that works every time if you do them the same way. So I'm going to show you two different algorithms, two different ways that we can divide larger numbers. I'm also going to give you a real-world problem here that this could be. This is 457 divided by 6. So the real world problem that would go with this is I have 457 baseball cards. I'm having a garage sale and I want to put them in groups of 6 to sell them. So how many bags will I need to do this? Okay, so we have an equal grouping situation. We're putting these baseball cards in groups of 6. I need to know, I don't want to take all my baseball cards to the store and to buy the bags, so it's just easier if I can do this quick, fast way, set of steps that works, and I can get an answer. So I'm going to show you the traditional, which is the way I was taught in school, and then I'm also going to show you Mr. Hill's way, and just a way that I came up with that helps the traditional algorithm make a little bit more sense, because a lot of people wonder, well, why does that work? How can you do that? So hopefully that'll answer this question as well. Alright, let's hop into it. We got 457 divided by 6. I'm going to start off with the traditional. You'll see my steps over here are pretty much the same. We're going to divide the big number into groups. We're actually going to use a little cheat. I'm going to show you how to do that. We're going to multiply because as we're dividing, we're going to do it in little pieces. So every time we multiply, we're figuring out the chunk that we just equally grouped, and then we're going to subtract, take it away, and figure out what we have left to still deal with, to still group. And then the last step is bring down, and I put a little star there because that is just for the traditional. And even with the traditional, I can probably show you a way that you don't have to use that step. But these are steps: divide, multiply, subtract, bring down, and I'll explain those as we go through. Alright, traditional. This is what it looks like. We're going to divide into the first digit here, which is kind of a cheat. We're going to treat it like just a 4 here. It is a 4, but it's really part of this bigger number, which is 457. We're going to treat it like a 4. We're going to ask ourselves, how many groups of 6 can I get out of 4? You can see with 4, I can't get a group of 6 out of there because there's only 4. So I'm going to move over here to the next digit, the 5. And now I'm going to treat this whole thing like a 45. Now again, remember, it's not 45. 457. We're using a little trick here, and I'll show you how that works over here. But for right now, you'll just have to wonder why. 45. How many times does 6 go into 45? I can get groups of 6 out of 45. So I'm going to think to myself, how many times will 6 go into 45? Without going over. I don't want to go over because then I could go over my 450 and it gets a little confusing. So I'm going to think, okay, 6 times 6 is 36. 7 times 6 is 42. I'm getting pretty close to my 45. 8 times 6 would be 48. That would go over. That'd give me 480 kind of, if you think of it that way. So I can't go over. So I'm going to go back to 7 times 6. So I'm going to put a 7 right here. And that was my divide. So I just figured out how many 6's go into 45. And I figured out 7. Now I'm going to come down to my multiply step. I'm going to go 7 times 6 is 42, and I'm going to write that right under here. That's my multiply step. I just did 7 times 6 is 42. And now I'm going to subtract. And this is where it gets a little confusing, because right here you're probably wondering, well, why did we subtract? What's up with that? Why did we do it? What we're doing basically is we just figured out, okay, there's 7 groups, which isn't really 7. It's really, if you think of a 0 here, it would be 70. And this would be really 420 right here. But we want to subtract and figure out, okay, well, what's left to still deal with? So I'm going to subtract my 5 minus 2, which is 3. My 4 minus 4 is a 0. It doesn't really need to be there, but we'll write it there, kind of dotted line, sort of not real obvious there, but it's there. And then this is the step of bringing down. Now, if you had a 0 here, you would be thinking of this whole number, but you're not. So you got to bring down. It's really part of your subtract. But if you want to bring down as a step, or if you just want to think about it as subtract, either way, you got to get that 7 down there. So the point is, though, is that there's 37 left still to deal with it, with the 6. We need to group this 37 into 6's still. Okay? So I went through all the steps one time. Now I'm going to do it my way, so you can kind of see what it looks like there. I'm going to do the same thing It doesn't work with my 4, just like it didn't work here. I'm going to come over to my 5 and think of it as a 45. And I'm going to put a 7 here. The only difference is I'm going to not ignore that 0. I'm going to put that 0 there. And I'll start showing you the traditional first, like what it would look like. 42. Only I'm going to put a 0 here, and I'm going to put a 0 here. And that keeps everything kind of intact. I'm not breaking my numbers apart too much. So now I can think of this as a fact extension, where you can do the 7 times 6, which is 42, and add the 0 on, and you get 420. So you can see that's my multiply step here. 70 times 6 is 420. And what that does is it keeps everything in order, and it makes a lot more sense as to why this works over here. So I'm going to go through my subtract step, and you see I don't need to do my bring down because my subtract step takes care of everything. There's a 37 there. And then what I'm going to do is I'm going to, just like this arrow goes right back up to my divide, I'm going to go right back up to my divide. Now in the traditional, it hasn't put a 0 there. The traditional leaves that spot open on purpose because it knows we're going to go right over to the next one, 37. We're going to know that 5 times 6 is 30, 6 times 6 would be 36. Again, you want to know your multiplication facts. It does help. 7 times 6 would be 42. I'd go over, so I know that it's 6 times 6 would be 36. I just did my multiply step. I didn't tell you there. I did it real quick. And now I'm going to subtract. And I get 1. 1 is smaller than 6, so my remainder is 1. Okay, so the traditional sets it up real nice. Your number is all set for you, 76. My way is a little different. I'm going to come over here and I'm going to do the same thing. I know that 6 times 6 is 36, so I would think divide. How many 6's go into 37? I know that the answer is 6. I'm going to write it above there, in the ones place, because it's just a 6. I'm going to multiply. 6 times 6 is 36. And I'm still going to get 1. Okay, left over. I'm going to write that off to the side here. Remainder 1. The only thing is here is now your quotient is a little weird because you have a 70 and a 6. Now if you put those together, it's real easy to just think, okay, well it's 76. But you can kind of look at it on a diagonal as well. But the idea is you want to put those two numbers together, 70 and 6. So your quotient would be 76, just like in the traditional. So either one. You might choose to use the traditional still, but hopefully this helps it make a little sense. But both of them give you the exact same answer. It's 76 with a leftover or remainder of 1. If I was thinking of that in terms of my real problem, I would have 76 bags that I need, and I would have 1 card left over. I'd have to decide if I wanted to keep that one or maybe just give it away at the garage sale or whatever. But that's how you do these two algorithms, the traditional and Mr. Hill's. And they both have the same steps: divide, multiply, subtract, bring down.